So thanks for coming, everyone. Thanks for being here on November 1st for this virtual workshop about teaching introductory statistics online. We have 4 presenters today, and we will have a second session next week, November 8th, same time. I'll send a new Zoom link beforehand. But anyway, we're here today. Let me talk about today's session, not next week's session. Our presenters today are Anelise Sabbag and Beth Chance from Cal Poly in San Luis Obispo, which is also where I am. And also the presenters we have are Laura Callis and Jennifer McNally from Curry College in Greater Boston in Massachusetts. I forgot to introduce myself. I'm so discombobulated here, but I'm Alan Rossman. Hello, I also teach in the statistics department at Cal Poly in San Luis Obispo. So let me, without further ado, turn it over. I think Anelise is going to be the first speaker among the presenters. So thanks to everyone for coming. Thanks to the 4 presenters. Please take it over, Anelise.
All right, just confirming that everyone can see the slides.
Yep.
All right, sounds good. So Alan just introduced all of us, so I don't think we need to introduce ourselves more. So we're going today to talk about in-person activities and how can we change those activities into an online setting, focusing on synchronous online and asynchronous online. So today, we're going to start with some of GAISE recommendations about active learning. Then we're going to talk about changes we've done and examples for synchronous and asynchronous classes. And we're going to finish with an opportunity for you to try it yourself, to change an activity. And we're going to be in the breakout review with you, kind of helping to do the discussion. So initially, what we have in mind here is just what we want to see in an online class is the same thing that we want to see in an in-person class, right? So we want our students to learn statistical concepts. And one of the ways that we can do this is through active learning. So we want students to be able to investigate those concepts by themselves instead of just passively listen the teacher explaining some of those concepts. And one of the ways that you can do this is by developing careful activities, right? And if students are working with other students, then we give them the opportunity to communicate those statistical concepts as they are explaining and working through the activity together. I think all of us who are here in this workshop presenting today, we really value activities. That's why we're doing this. And we really hope that will be helpful to you. Like think about different ways that we can do activities in online courses. So I'm going to stop sharing and let Laura take over.
You muted or?
Thank you. So I teach at Curry College. We are proudly neurodiverse campus, and I teach in person and I teach online, and I teach both asynchronous and synchronous online. But what I found is that even if you are teaching asynchronously, you usually have a session like your office hours where students come together to work through problems that they might be experiencing. And even if you are teaching synchronously online, there's going to be folks who can't make it. So you're kind of always teaching both, or at least I am always teaching both. And these are some of the things that I've had to think about when I choose different tools for doing that work. I think when you do have a synchronous component of your class, maybe you're teaching hybrid or something like that, one of the biggest benefits is that it gives you the opportunity to elicit and make sense of and react to student thinking in real time. So in order to do that, though, you have to think about how are you going to gather data on student thinking in real time. I think a lot of folks who have been in Zoom meetings know that you can use reactions and polls in Zoom. You can use Zoom chats, and one technique that people have found valuable is using a waterfall approach. So instead of just asking people to put an answer into a chat, telling people, okay, I want you to write your answer for 1 minute or for 30 seconds and don't hit enter until I say go. And that what that does is it's kind of like raising hands in an in-person class. So if you just have people hit enter whenever they want, you're only going to hear from the fastest typers, right? Just like if you don't use hand raising, you might only ever hear from the people who are the fastest to talk, and then participation will go go down over time because people are just expecting, I don't know, Johnny to be the one to answer. So that might be a tool that you can use. But I wanted to show you some other tools too. So I use Desmos a lot. And I'm going to put the link in the chat in case you wanted to poke around. And my bar went away, so I'm just going to stop share for a minute because my toolbar went away, and put the link in the chat. And you don't have to sign in. If you do sign in, it'll save anything you write for yourself. I'm already signed in, so I'm just going to make up a name. And what Desmos does is it was designed for math education. So there's lots of different slides that you can make that can help you do mathy things. So there might be multiple choice answers and students can explain their thinking and then you can see their thinking. This is a card sort. So if you want to see really quickly if students know how to write the null hypothesis with symbols, you can get them to link these different cards together. There's tables. Some of these tables will even calculate values for students. It's a setting you can set so that if you have students who are struggling with arithmetic, that can help. You can have students do graphs or draw pictures, or you can insert a picture and have students annotate it. And there's links that you can put in so that students can go directly to an applet or directly to a data set. If you're running a simulation, for instance, and you want to know, well, okay, you pretended the null hypothesis was true and you flipped a bunch of coins. What was the result? Students can indicate what they got and then see the sampling distribution of everybody else in the class. And of course, multiple choice, again, it's just a different way of looking at multiple choice. The real benefit is I think the teacher side. So on the teacher side, I can see if I go to summary, everybody that's in class. And I can anonymize it so that I don't know who's who if I'm worried about, favoritism or something like that. And I can say, oh, Jen, I see you're still over on slide 1, maybe in the chat or in a note, like, can you come join us over on slide 3 now? So it really helps with pacing. But also I can see like, everybody's really getting slide 2 wrong. Maybe I need to pause. And I can click and see individual responses too. So over here, this one's wrong because they haven't done anything. Over here, if I click on this, I can see what is happening, whether they've gone wrong, what they're missing. I can click on the overall slide too and get a visual that shows me how everyone's doing in general. So I could see like, okay, well, folks aren't done yet, or, oh, Marie really looks like she knows what she's doing. The LKC, I might have to have a conversation with her. And I can see that also in something like, maybe this one over here, I can see, oh, people are mostly picking number 2, and that's not really the right answer, or that is the right answer. And then if I scroll down, I can see their explanation. So it kind of helps me to hold students accountable because I can see if they're doing anything. I can get data on their thinking really quickly, and it kind of aggregates their thinking too. So, oh, everybody's doing it this way. I need to pause and really talk about that particular misconception. So I use that a lot. But it's very individual, right? So everybody's kind of working on their own Desmos slides, and we're talking about it as we go, but sometimes I want students to collaborate too. And so Google Slides and Google Docs are really good for that. So I'm going to put this link in the chat, but you don't have to follow it. It's really just for your reference. I'm going to show you everything on the screen. So that's in the chat. So in the Google Slides, you can make slides that still have a little bit of anonymity. So this is an example where I was introducing standard deviation, and we were talking about it in terms of tips of different workers and which shift had the most fair distribution of tips, where everybody was kind of the same, and which one was everybody kind of different. And they can drag these smiley faces to show which one is most fair, or which one is they think is most fair, or which one is least fair. They can drag it and put it there. And I can kind of see in general what people are thinking. If you want like a little bit more accountability, you could have students vote and put their initials down so that they're a little bit anonymous to everyone else, but you can kind of see where the trends are and you can kind of hold everybody accountable for actually doing some thinking. But really, I think the big benefit is in small group work. And so often I'll have students work through the whole investigative process where they're writing about the research question, they're describing the study, they're exploring the data, and I'll have links to the different data and the different applets in there too. And so they're kind of collaboratively discussing and creating this document together. So it's a little bit more friendly for group work in that way. And of course, there's small group chats. You can listen in when people are talking in their breakout rooms, or you can have whole class shareouts, just like with a regular session. I think another one of the things we have to think about is everything is a little bit slower in an online environment. Like students need a little bit more wait time. Things just kind of happen slower because you have to share links and things. And so one of the questions I'm always running up against is how I can maximize the time spent talking and processing together. If you're teaching hybrid, you only get to meet like half of the time in real time. So what I do is I choose a subset of questions, the ones that I think we really need to jointly process. I might accept less formal writing or use question types that require less writing. And then in order to get people to actually be talking in their breakout rooms, we might think about the size of those rooms or the norms. So I usually know like who can actually talk, in that particular class versus who might be, at work or something. And I might have students say, oh, if there's somebody you want to work with, send me a direct message, and I'll make sure that there's groups that have sort of existing social relationships. But also in the breakout room, you can just have students start with an intro question or some kind of norm. So often I'll have them say, okay, everybody has to say their name and what superpower they would pick if they had a superpower before they start engaging with the content. And that way people are more likely to talk if they feel like they know someone a little bit. And, I have discussion board prompts too, where people kind of introduce themselves to each other before we even meet. Another thing that I know other instructors do is they have students choose their breakout room, and they might have a breakout room where everybody wants to like go through the questions together. And they might have another breakout room where people want to be together to ask each other questions if they get stuck, but they actually want more quiet think time and work through it individually. And then that way students can kind of choose their level of participation and their form of participation. So I think just thinking about it purposefully and thinking about your particular students is what you need to do in order to really maximize that time processing together. Some other things to think about is student engagement during the live sessions. So different levels of being anonymous can, like varying that can increase and broaden participation. So some students are really, really shy about their beginning thinking, and they might need to be anonymous from you because they're worried you're going to judge their first thoughts, or they might need to be anonymous from their peers. And so they might not feel really comfortable putting something into the Zoom chat with their name on it. So what tool you choose is going to offer different levels of being anonymous. So in Desmos, you can have students see their peers' work, or you can turn that option off if you feel like your students might benefit from a little bit more anonymity. On the other hand, there are students who need that accountability. They need you to know that this is their thinking in order to participate. Otherwise, they're going to take a back seat. So kind of varying the degree to which you know who is saying what can help. Multiple modalities too. Some learners are like, my son is like this. He needs to talk his ideas out first before he can put any pen to paper. That used to drive me crazy when I was a learner. I was like, oh, there's so many voices. I just need a minute to think. And then I'm happy to participate. And if you think about a live classroom, right, you would have like turn and talk as a talk move, and you'd have stop and jot. So how can you recreate that in the online environment where you give students an opportunity to do both? To increase participation and engagement. But I think it's really important to think about your own work too as the instructor. So are there ways that you can aggregate students' thinking, the ability to like quickly see patterns so that you can react in real time? So for me, that's Desmos, because I can look on that teacher slide and see like, oh gosh, everybody is picking this answer. And so I think I need to revisit this, or I think I want to have a couple of people share out who have gotten the right answer. And I could say, oh, you had such a good explanation. Do you think you could share out? So being able to see those big trends in real time can be really helpful. I think also you have to think about the ease of adjusting in the moment. So Desmos slides are kind of locked down. Once you send the link to students, you can't really change them. You can hide them, but you can't change them. On the other hand, like Google Slides or a collaborative whiteboard, you can make changes in the moment. So if you find yourself using a level of inquiry where you need to pivot a lot, you might want to use one of those more flexible tools. And then are there mathy tools as well? Like, can you create graphs and formulas? Is it easy for students to do that as well? And then when you're choosing a tool, I think too, like after the live session, thinking about what happens. So for students who couldn't attend, how can they get caught up? So for me, I use Desmos, and they work through the slides, and they just send me an email when they're done, and then I'll go in there and put comments. You can write students' comments on their work by using this little button right here and saying, you know, good job, it's actually more like this. Or sometimes I just directly email them after looking at their work and saying like, oh, you got number 5 wrong, it's actually more like this or something. But then maybe other tools are not really that useful for students in terms of getting like caught up and working through the process as much. And then I think thinking about useful artifacts created for students. So you might have had a really rich discussion and used manipulatives and talked about a lot of really good ideas, but if students weren't taking their own notes, that kind of all disappears, right? And it's particularly true for us because we have students who are very smart, but they struggle with memory issues, or they might have a disability that stops them from being able to take notes and write. So what kind of artifacts are created so that students can go back and it can kind of jog their memory about what was discussed. So the Desmos, they are the artifacts, but I know other instructors use collaborative whiteboards, and then they'll take a picture of the whiteboard and they'll post it on Canvas so that students can go back to that to refresh their ideas. One of the other challenges that's true in any kind of online environment is what are we going to do about manipulatives and collaborative data collection? So students don't have decks of cards, or at least full decks of cards, because their children play with them at home, or they might not have dice, right? Or they might not have coins or something that they can flip. So there's a couple of links in here for virtual manipulatives that you can have students use. And then also when we're working together in real time, often we are looking at creating a sampling distribution. So I modeled the null hypothesis, and Anelise modeled it, and Jen modeled it, and we want to put our data together to see, well, what typically happens when the null hypothesis is true. So how are we going to kind of pull all of that data together? Desmos does have some data collection slides that are pre-built, but other people also build their own different kinds, and you can just copy them and put them into your set of slides. I use Google Forms a lot too. So Google Forms is just like you make a survey. So you might have people enter in what they got for their, their simulation or something like that. Or you might be collecting data on students and you want to analyze data on students, because then they can kind of see themselves in the data. And so they fill this out and it automatically populates into a Google Sheet. This is from a different survey. And so you can just copy and paste this data into an applet, or you can copy and paste it into any other kind of software that you want to use. Or you can just make the graphs in Excel if that's what you're looking at too. So it allows you to do it really quickly in real time. So, second, I'm going to the next slide. So those are just some of the big things, but I think sensitive touchpad. I think the big idea is thinking about, okay, well, what would I do in a live class, and how would I make that happen in an online space?
All right. So now we're going to go through some of those changes, but focusing in an asynchronous course. So the idea here is, as Laura was explaining, like she's right there with the students in the class, even though it's online, but it's synchronous. In this example, students are completing the activities on their own whenever time they have to do this. So the key idea is we need to anticipate, where do we think students will struggle? What is statistical concepts, or what is specific questions do you think students might get stuck with? Right. So in an online setting, we always need to be even more careful when we're writing questions, when we're giving the activities, right? Because you're not going to be right next to the student if they have a question for you. So being very careful with the scaffolding, that is present in your activity. Whenever possible, let's try to give, immediate feedback to students. And right now I'm going to show you some examples in a couple of slides. I'm going to show you an example in a statistical activity where we're doing that. So, and maybe we can give immediate feedback using videos, right? A lot of times in our activities, we do hands-on simulations when we are in an in-person setting. So how does that look like for an asynchronous setting where we're not able to gather data from every student in the classroom? So what can we do to support that student? Are we going to do a video or something else? And then thinking about this, a lot of times we're working with our students and gathering data from the class and then analyzing this data. So one thing that we can do is we can gather data right at the first week of the course, maybe using just a quiz, right? So I have a quiz where I ask students a couple of different questions. And once they answer that, I can use that data throughout the quarter. And of course, even though we're not right next to the students, we still want the students to be able to ask questions to us. So in an asynchronous setting, it's very important to have that location. So every week in the course, I have what is called a question forum, where students can go in. If they have any stat questions, they can post there. Everyone else can see my answers. So this is just available for everyone. So let's take a look what that would look like in an example. So here we're going to go through an activity called Can Dog Understand Human Cues? This is an activity from the ISI textbook where we have a lot of the authors here. And this activity is done very early in the course. Okay, so here, some of the ideas that we're talking about is what is an observational unit, what is a variable, what is a statistic, and what is this idea of randomness. So all of those ideas are introduced in this activity, and we're assuming that students are still going to struggle a little bit with them. And then what we want in my class, what we do is I just give a PDF or a Word version of the activity to the students, and students individually complete this activity, and then they upload the answers to Canvas. Okay, so this is kind of the setting that we're going to go through here. And we're going to start with some small changes. And one small change that we can do is the one I mentioned. Let's give immediate feedback to the students. So in this activity, we're talking about a dog. The research question is, can dog understand human cues? So there is this little doggy named Harley. And what is happening is there is an experimenter, which is about 2.5 meters from the dog. And there are two cups on each side of the experimenter. And that experimenter is either going to point or bow to one of the cups. And the idea is we want to see if the dog Harley will go to the correct cup. If he can understand the human cues, he might go to the correct cup. So this is kind of the idea of the study. And we start with questions. And here we're told before the questions, Harley was tested a total of 10 times. And in 9 of those times, Harley went to the correct cup. So here what we have is the overall description of the study. So now let's think about what is an observational unit, right? Or what is the variable in the study? If again, we're doing this in person or synchronously, I have no problem leaving those open-ended. But if we are working with students in an asynchronous setting, then what I want to do is maybe change those to multiple choice questions, right? So here, when I ask what is an observational unit, I'm going to have maybe options A, B, C, or D. But remember, you don't always need to have like 5 distractors or 4, put however many you have. And ideally, those distractors, distractors are the alternatives that are not the correct answer. There are going to be some plausible answers that you think students might choose. So when I gather data in class, when I ask what's the observational unit in an in-class setting, a lot of the students would answer Harley. Or they will answer the variable, whether Harley went to the correct cup. So you can see that option A is actually Harley and option D is actually the variable, right? So the correct answer is Harley's attempts. But those kind of plausible incorrect answers are listed there for our students. One thing for us to keep in mind is when we're doing this, we need to think, is this like we're giving feedback? We can tell the students if the answer is right or wrong. But we don't know if necessarily I want to grade or be like punitive, take points off if a student get this question wrong. So the way I do it in my class, I just want them to go through. And if they completed the activity, they get the points. So if you are grading, think about partial credit here. So it might still be worth it to give students some of those points. And then here in the second question, where we're asking about the variable, one of the distractors is actually the research question. And again, this is something that I observed during class time. When I asked, what's the variable? They say, oh, whether Harley can understand human cues. I'm like, no, that's actually the research question, right? So anyway, this is one example of what you can do if you want students, as they're completing this activity by themselves, we want to give them and support them, give them confidence that they are on the right track, right? And if they are not, we want to give them some resources. Is everything okay? I heard some noise. Okay. So now we're moving on to another small change that we can do. One thing that we can do is, if we think students might struggle with some of the new concepts that they are learning, maybe we can add those definitions to the activity. So here you can have a definition talking about the idea of sample size, statistic, observation units. Maybe you might even want to use a hyperlink. So if students are struggling or they might be getting the question about observational unit wrong, they can click on that link that might take them maybe to a glossary. So this is one example. And again, you might be doing this already in your in-person class, but here we're just calling your attention. In an asynchronous activity, this is even more important to have those resources readily available for the students. Something else to keep in mind, keep questions simple and focusing only on one idea. So here is a question that we ask. Determine the observed statistic and produce a simple bar graph. In an online setting, asynchronously, maybe you want to split this into two questions. The first question being, what is the observed statistic? And this can be a numerical question or multiple choice. And the second question being, create a bar graph, or it can be a multiple choice question with different bar graphs. And again, we want to pay specific attention to the idea of the observed statistic because that's a topic that is so important, right? In this case, it's either the count or the sample proportion. And students are going to use this later on when we get to the idea of the p-value, right? So in this example, our observed statistic was the 9 correct attempts out of those 10, or if you're using proportion, it's going to be 0.9. And here's what a bar graph could look like. And again, if you're doing multiple choice questions with the bar graph, you might just have different bar graphs showing different distributions. Next, in the activity, what do? We think about, could these results of 9 out of 10 correct attempts have happened by chance alone? So we asked the students, is this possible? That's the idea of question 7. And question 8 is asking, is this likely? If Harley was just randomly choosing between the two cups. So what we want here is we're guiding to the students and what would random chance look like in this activity? So students would actually go on and do a simulation by flipping the coin. The problem is in class, it's easy. Students are flipping a coin 10 times. I gathering the data and I'm combining all of them into a dot plot, right? So that's the question that we have, simulate one repetition of Harley, guessing randomly by flipping a coin 10 times and combine your results with the rest of the class. In an online setting, that is not possible, right? We don't have students right there collecting the data, and we want them to do it. There is a reason why we ask them to do it in an in-person class. So what we're doing here is a way to get out of this might not necessarily be to create a video, but here I just did an example and I said Julia simulated one repetition. I actually showed the 10 coins and I asked follow-up questions. Why did Julia flip the coin 10 times? How many heads did Julia obtain? And then I tell the students, Julia repeated this process a total of 11 more times for a total of 12 repetitions. And then I ask them to count the number of hats here. And here they will already understand that the number of hats is the number of successes in that trial of 10 attempts. Then I ask the students to fill out this last column and create a dot plot, showing the distribution of the number of hats or the number of correct attempts. And we need to be a little careful here because some students use the iPad nowadays and it's very easy for them to put a dot on the plot. And here I just try the students to do the asterisk thing, when they input it to be a little easier. But a lot of times students just do it and they take a picture or there's a lot of variability. Students are able to kind of figure out this part. But what would this plot show? This plot is showing, what we would have done in class, right? Gathering data from all the students. And here, I still want students to do that, right? So after students go through that example, I ask them, now is your turn. Simulate one repetition, record the number of hats, and add your data to the plot. So I'm kind of asking proof, so I still want students to do this, and I'm still going to ask them, and you can see I have a little note, like you're really supposed to flip a coin 10 times. This will help you better understand the simulation. So I'm doing the best that I can to make sure that students would actually do this, right? And you can even use, there's the flip videos where students can record themselves doing. So that's another option of proof that they did it. But in this activity, I did not. I just asked them to report and add their dot on the plot. Then one thing to keep in mind is simulation, the idea of a sampling distribution, the distribution of sample proportions under the assumption that the null hypothesis is true, those are a little complicated ideas. So we want to make sure that when students are getting to those, that they're actually understanding. So we need to provide like more information, or maybe we can add a couple of questions to help them in this scaffolding process. So in the in-person activity, right after students do the simulation, we're going to say, where is 9 heads on this distribution, right? But maybe in an in-class setting, I've already talked with the students about each dot on the plot, and I won't be able to do this in an online setting. So maybe I'm going to ask that question. Using the context of the study, explain what a dot on the plot represents. And then I'm going to ask them, where is the 9 heads in your distribution? And maybe you can even ask a question before this, asking, why are we focusing on 9 heads? Where is this coming from? Students follow up with an actual simulation using 1,000 distributions in using an applet, right? And we give them all the instructions to do it. But again, in an online setting, we don't know if they're actually following through those steps. So when they get to question 14, which is again saying locate where 9 heads is on the plot, if students don't have the right plot, then we might be leading them in the wrong way. So one of the things that you can do is, first of all, ask them to provide a screenshot. So they follow the instructions. They did 1,000 simulated samples, and now they paste their screenshot of the distribution, of the node distribution. And if you want to make sure that they are on the right track, maybe you tell them, at this point, you have a little follow-up. You should have a distribution that looks similar to the plot below. But if you're a little uncomfortable that you're kind of giving the answer to the question, what you can do is you can just give a little tip, or you can describe it. And you can say, at this point, you should have a distribution that looks symmetric and bell-shaped and is centered around 0 with values varying from 0 to 10. So again, you're asking them to show proof of the work that they're doing. We're giving them tips to make sure that they are in the right track, but we're keeping this as an open-ended question, right? This is not one of the questions that maybe you want to turn into multiple choice, because you actually want to make sure that your students are doing it. Another example of questions that you might want to still keep open-ended is a question where we ask them to make a conclusion, or where is a question that we ask them to look back and then look ahead. So thinking back of the original research question, what additional studies would you suggest that we conduct? So this is an example where let's keep this open-ended. Let's see what the students are answering here. And there is not really a right or wrong answer, especially for this last question. This example that I gave were some simple changes that you can make to an in-class activity to turn into an online setting. And I'm hoping that maybe you're already doing some of those, but there are bigger things that we can do. And in my view, they're mostly tied to like videos that we can add. And I categorize them as summary video or explanations video, or maybe a wrap-up video. So let's look in this activity where I might put some of those options. So here we have, where would a summary video appear? At the end of this activity, we guide the students to a little review where we talk about the idea of the 3S strategy, which is something that they just did, right? The statistic, the simulation, and the strength of evidence. So in this example, students will just review what they did. They will provide, again, the statistic of 9 out of 10, the simulation, how they did it, and the strength of evidence. Maybe this is a good step to just leave those questions open-ended and add a summary video here going over the idea of the 3S strategy. This is a strategy that they're going to use in all the next activities in the course. So why not just keep this open-ended, make sure students get it, and add a summary video to, again, ensure that they're going on the right track here and understanding a concept that will appear many more times in the future. How about an explanation video? Maybe this is a part where you think your students might get stuck, or they might need some extra help, and you're not there in person, but you might have a video helping them here. So at the second part of this activity, we talked about, can dog understand non-human cues? So it's not a person pointing and bowing, it's actually a mechanical arm that is pointing to one of the cups. And then we tell the students that Harley did this test, and out of 10 times that Harley was tested, Harley chose the correct cup only a total of 6 of those times. And on question weight, we asked students, using the dot plot you obtained from the previous simulation, what would you consider 6 unlikely? And then we guide the students to work on this second part of the activity and even making some comparison between the two studies. This might be one that might be a little more challenging for the students. Maybe students don't understand, why are we doing the same simulation? Why are we using the same simulation? Why don't we need to do a new simulation here? Now, so this might be a time where you're actually going to provide a video and help the students understand where is the location of the statistic on the plot, talk about the idea of your results possibly have happened by chance, and even compare the two studies in that video. Okay, so this is one example. A simulation video here, I did not use a simulation video in this activity, but if you have an activity where the simulation is needed, then this is an example of the contagions yarns activity. I actually did the simulation by hand, and you can see that it's very poorly done, right? It's not fancy. It's literally me shuffling cards and writing things in the table. So we want to be able to, we give these opportunities for the students to, see what you're doing, and it doesn't need to be fancy. And as a reminder, when we're talking about videos, and those take time for us to do it, please remember that we're talking about shorter videos, like 5 to 8 minutes, maximum 10 minutes. And if you can, try to keep track if students are actually watching the videos or if they're not watching the videos. And the final thing that I wanted to show you here is there is other resources that you can share with the students. And this is an example of a zyBooks. So they took the book from ISI, that was an online version of the book, and they turned to a version of using animations. So this is a great resource for an online class, where this is an example of the rock, paper, scissors activity. And here you have students, and they actually seeing the animation with the rock, papers, and scissors. Students still need to be engaged, so they are still having to click this. We see the distributions, and we only care in this example whether students played scissors or no scissors. And we get to the final part where they actually have the statistic, which in this case was the proportion of times that someone played scissors. And this is follow up with questions about observation unit, binary variables, so on and so forth. We talked about the known alternative hypothesis, and I want to show you this specific animation where they actually show what the simulation will look like. So they start with the observed results. They move on to do a simulation under the assumption that there is 1/3 chance that someone will choose scissors, and they repeat this a total of 12 times to mimic what happened in the study. And then they do a repetition of this setting for a total of 100 times. And then for each one of those, calculating the statistic for the simulated sample. And then we end up with the plot of the null distribution showing the distribution of sample proportions. So this is just another example of things that you can share with your students that will keep them active, and will be good resources that already have, they were well designed, knowing where students might struggle. So this is the part that we talk about an example using a synchronous class. And now I'm going to let Jen take over.
Sounds good. Thank you very much. And I'm just going to share another example of how we could have an asynchronous class that really embodies active learning. One of the things that I struggled with was when I started teaching online, I was like, I need to make this as consistent as possible to my in-person class, but it was really hard to do so when I found that the active engagement of students was what was really important to their learning. And, how do you replicate that if you may never see your students at the same place at the same time, or actually listen to them in real time? So I struggled with that a lot, but I found that if I really got to the core of what I valued in the classroom, which was that students needed to discover ideas before formalizing them, and that they needed to do the statistical thinking, that I was able to rework what I give for class activities so that I use consistent materials and tried to replicate that same approach with my asynchronous online class. So the way I thought about it was I thought about the ways that I could keep the activity as authentic as possible, but use a lot of those tools like Anelise was saying for the the automatic grading so that students get immediate feedback whether or not I was actually able to look at their work personally. So I broke the investigation activity. Again, this is an example of an exploration from the ISI textbook. And I wanted to keep the questions fairly the same, but like Anelise said, some of them worked better as multiple choice questions, others were better as fill in the blank questions, and so on. So that students really did have that experience of sort of puzzling through what the investigation was asking them to do. So I wanted to structure the students' tasks so that they had active engagement with the ideas. I didn't want to give things away, but I also knew that my students needed a degree of scaffolding and support because giving them a long text to read just wasn't part of their preferred way of learning something. So I decided that I was going to create videos that sort of did the same thing that I do in my in-person class in an online environment. I found that when I gave my students an exploration in a fully in-person class, I would sort of unpack the context first so that students understood what it was that they were doing and they could sense what the researchers were really studying and the conditions of the experiment or observational study. So the first video helps students to locate the instructional resources that they'll use, some of that housekeeping stuff, but then it really unpacks what is the study, how is it set up. In this case, it was the tasting water exploration. So they were at a festival and they recruited volunteers to drink from 4 different cups. 3 of the cups had different varieties of bottled water, and 1 of the cups had tap water. And the research question was asking, do people really prefer bottled water to tap water? And so students needed to sort of experience that and hear it. And so that first video breaks that down. Students then answered questions that were about the first few steps of the statistical investigation process before they came back and watched another video. So there's a total of 20 minutes of video in this particular exploration, but I've broken it into 6 different episodes. And I've interspersed those episodes in between the active engagement that I want students to do. And it was very similar to the types of breaking up into small groups for students to discuss and then coming back together as a full class is in my in-person experience. So as much as possible, I wanted to give students time to experience the statistical thinking and statistical ideas, and then come back to formalize it, paying particular attention to the statistics vocabulary, the symbolism, and so on. So that's what I was attempting to do with these. And like Anelise said, you need to anticipate what students' needs will be and scaffold that as much as possible so that the time that students are spending on these tasks is really focused on developing their conceptual understanding of inference. So this is another example of the second video that would come for this exploration, where I basically go over the answers for the first couple of questions while formalizing it and providing some key vocabulary and additional context for students. The other change that I made was in the discussion boards. I find it really important for students to hear a variety of ways that people think about statistical ideas. And in class, we're able to do that by sharing out what our answers are for particular exploration questions and hearing what may be valid or what may be attractive but invalid, and sort of unpacking the ideas that really underlie what students' productive and less productive conceptions are. So what I've decided to do for my discussion boards is to present students with 2 sample student ideas and have them identify which student they agree with and whether there's any misconceptions or shaky ground that the other student is on, so that we can highlight what those misconceptions might be and try to reform them into things that are statistically valid. So as much as possible, I wanted my asynchronous online class to replicate some of what I knew was working well in my in-person class. And that's just some examples of how I attempted to do that. So thank you.
All right, this is good. So what we're going to do now is, first of all, sharing my screen. And we're going to give you an opportunity to actually try to do this, like thinking about where would you change this activity? What would you do in a specific part of an activity? And the activity we're going to do is called Contagious Yawns. But before, let's just give a big picture of what we're hoping to do. We give you a screenshot of what the activity looked like for in person, and we're going to share that Google Doc with you. So it's just going through that activity and thinking where we might want to change something, thinking about students in an online class. We're going to split you up in breakout rooms according to the type of classes that you're interested in. If it is an asynchronous class, if it is 100% asynchronous, 100% synchronous with some online and Zoom meetings, a hybrid class, and maybe if you don't have a preference, maybe just a no preference group. Once you choose your option, then we're going to share that activity with you using the Google Doc. This activity is also from the ISI book. And then think about this. This is the first time that students are working with two variables, an explanatory and a response variable. This is the first time that they're comparing two groups, so there may be some group with some sort of treatment and a control group. And this is the first time that students are working within a statistic, which is not just a proportion or a mean, but it's now a difference in sample proportions. So these are some ideas for you to keep in mind. And I'm going to stop sharing my screen now, and I think Alan is able to split. Is that correct, Alan?
Yeah, I'll create 4 breakout rooms, and I'll give participants a chance to choose whichever room they want. Maybe you could share your screen again to remind them what the rooms are, 1, 2, 3, 4.
Yes.
And can you put the link in now before we leave as well?
Yes. So just 1 second. My computer currently hates me. So let me copy this, and I'm going to paste this link in the chat. And then I'm going to go back to this slide. And these are the 4 options. 1 is 100% asynchronous, 2 is 100% synchronous, 3 is hybrid, and 4 is no preference.
Great. Thanks to Jen for putting that in the chat if you'd prefer to look there. And then, so there's the Google Doc. It's probably helpful to click on the link to the Google Doc before you go to the breakout room. I have now.
And now the breakout room leaders have it too.
So yeah, go ahead, and I think you have the chance to pick whichever breakout room you want, 1, 2, 3, or 4, according to what you see on the screen or in the chat.
All right. Thank you for being the breakout rooms with us and participating. We appreciate that. And just a heads up, next Friday we have another workshop. And in this workshop, we're going to talk about interactions in online course, how we can help, and support students in synchronous and asynchronous settings to work online together or asynchronously, and group works and all that beautiful drama that sometimes is very hard in an online class. So thank you for being here, and we look forward to seeing you next Friday. Bye.
Thank you all.
Thank you.
Oh, good. There's some people that say that they need help with this. So yay, Trevor.
Me too. See you next week.
See you.